Welcome back, focused learners. Today, we're diving straight into an explainer that completely redefines how we build and interact with AI. We are peeling back the curtain on how production AI systems are actually being built right now, looking ahead to 2026. If you've been drowning in buzzwords and wondering what's really happening under the hood, well, you are in exactly the right place.
Okay, let's dive into this. Prompt engineering is dead. Welcome to the era of loop engineering. I know, it sounds like just another internet hot take, right? But honestly, it's not. This represents a massive, fundamental shift in AI architecture. We're officially moving away from treating AI as this static text box where we obsess over tweaking words, and we're moving toward building dynamic, robust systems. By the end of this explainer, any confusion you have around AI agents is going to completely vanish.
So here is our roadmap for today. We'll cover the 3 eras of AI, the anatomy of an agent, harness engineering, managing context rot, verification and judgment, and finally wrap it up with the Mint framework. All right, Section 1, the 3 eras of AI. Let's get some essential historical context out of the way first. Think back a couple of years. The absolute highest leverage skill was prompt engineering, right? Just tuning exact input words for rigid models. Then the bottleneck shifted to what the model could actually see, which brought us into context engineering, or RAG. During that phase, the main job was curating retrieved documents and feeding them into the context window. But today, we are firmly in the 3rd era, loop engineering, or agentic AI. Models can now write their own prompts, they can use tools, and the human's job has entirely shifted to designing the autonomous cycle itself. Now, the distinction here is absolutely critical. In RAG, or context engineering, your goal is pretty static. You're just assembling the right inputs, retrieving data, and essentially hand-feeding the model so it can spit out a response. Agentic AI, though, a whole different ballgame. It is all about designing the system's architecture. Instead of just generating text, an agent acts, observes, verifies, and retries dynamically. The human role transitions from just curating documents to actually engineering the system cycle and its boundaries. Moving on to Section 2, Anatomy of an Agent. Let's zoom in on what's actually happening inside that loop. To really ground this, imagine a customer support agent checking a refund policy. An AI agent is essentially defined by a primitive loop, specifically the React pattern. Step 1, the model acts, say, calling a lookup tool. Step 2, it observes. A harness executes the action and hands the result back. Step 3, it verifies that result against the policy. And Step 4, it either retries or responds. Unlike standard AI, this agent is an autonomous entity pulling its own context through tool calls until it finally has what it needs to finish the job. But here is the piece almost nobody engineers, the stopping condition. Like, when does this loop actually end? Because without deliberate stopping conditions, you get runaway loops. The agent gets confused, just keeps calling tools, and spins indefinitely. This literally burns through massive token budgets and sends your inference bills straight through the roof. You need explicit triggers, a clear done signal from the model, a hard cap on iterations, strict cost budgets, or automated verifiers that pass and finally end the cycle. Which brings us to Section 3, harness engineering. This is all about ensuring reliability at the macro system level. Now, what's really interesting about this slide is when people build agentic systems, they get totally mesmerized by the unpredictable, creative nature of the AI model itself. But if we're being completely honest, that AI model is often only about 5% of the magic in a production system. The remaining 95% of the reliability, that comes from the harness. This is the real core of agentic AI as an engineering discipline. It's the boring, deterministic, traditional software wrapped around the model. Database slow? Well, you need a timeout. Tool call fails? You need retry logic. Model spits out malformed data? You need fallbacks and strict guardrails. Trying to optimize an AI model without a bulletproof harness is literally like putting a Ferrari engine into a car with no brakes. All right, Section 4, Managing Context Rot. This is the primary pitfall you are going to face when running these complex loops. So as your agent iterates, every single tool result and reasoning step gets appended to its memory window. Over time, this leads to context rot. This is the measurable degradation of a model's quality as its context fills up with stale, low-signal tokens during a long task. It is exactly why long-running agents often start out incredibly strong, but then hallucinate or just completely fall apart halfway through. Basically, they drowned in the noise of their own history. To fight context rot, you have to budget your context exactly like you budget money. You can use compaction to periodically summarize earlier steps. You can use external memory to store facts and retrieve only what's absolutely relevant. And crucially, tool result management. If a database query returns 1,000 rows, filter it before you just dump the whole thing into the model. In fact, spinning up multi-agent systems using sub-agents to handle messy tasks and just return a clean, tiny answer is actually one of the most brilliant context management strategies out there. Let's shift gears to Section 5, verification and human judgment. This is the hinge that the entire loop turns on. There is a very strict divide where automation should end and humans absolutely mess up in. Automated verifiers are your cheap, reliable binary checks. Does the code compile? Is the refund strictly under $100? You bake these directly into the loop so the agent can self-correct. But human-in-the-loop checks? Those are for the expensive, subjective questions. Like, was the refund decision actually nuanced and reasonable for this specific customer? There's no cheap automated check for empathy, and that is precisely where you put a human. And this brilliantly illustrates how the pioneers of the field rely on 4 famous agentic design patterns established by Andrew Ng. These act as the literal building blocks living inside our customer support agent's verification loop. Reflection is the agent checking its own draft. Tool use is the database lookup. Planning is sequencing the steps. And multi-agent collaboration uses sub-agents to keep the context clean. These aren't just abstract theories, guys. They are the actual gears of the system. Building this software involves 3 nested loops running at totally different speeds. The inner loop is agent coding, running in seconds or minutes, where the AI writes and tests. The middle loop is developer feedback, running over minutes or hours to review and steer the specs. And the outer loop is external feedback, running over hours to weeks to gather real-world data. Notice the asymmetry here. The further out the loop goes, the more your verification depends entirely on human judgment and real-world feedback rather than just automated agent checks. Finally, Section 6, the Mint framework. This is your blueprint for building these complex systems without creating an unmaintainable mess. Mint stands for Minimal Intelligence Necessary Tools. The philosophy is super simple, but incredibly hard to follow in practice. Build the minimal viable system end-to-end before adding a single layer of complexity. Seriously, do not bolt on vector databases, complex long-term memory, or crazy multi-agent frameworks on day one. Complexity should only ever be added when there is a real, observable bottleneck that demands it. Let's move to the steps and see how this builds intentionally, layer by layer. Step 1, start with a basic prompt workflow just to get the agent answering end-to-end. Step 2, add tool use for actual lookups. Step 3, add continuous evaluation to measure your resolution rates. Step 4, add state and memory across conversations. And Step 5, only at the very end, add a human in the loop for those weird edge cases. Because think about it. If you wire up 5 agents at once and the whole thing breaks, you're not going to have any idea which layer failed. Iterate incrementally. We've covered an immense amount of ground today, from moving past prompt engineering to designing deterministic harnesses and managing context rot. But I want to leave you with a provocative thought as we wrap up this explainer. Right now, the human's job is engineering the loop and the harness to keep the AI on track. But as we transition fully into this agentic era, what happens when the AI becomes capable of engineering its own harness? Truly something to think about. Thank you so much for joining me, Focus Learners. Keep building, and I'll catch you in the next explainer.